In a previous video, I made a little PCB heater out of a chunk of brass and an old soldering station, which was quite successful. So then I started looking at AliExpress, and I noticed these little PCB heaters that they have, and they kind of looked interesting. I thought myself, I'll get one and check it out. Well, to make a long story short, it wasn't very good. This particular one should have been designed like this originally. See, it's got countersunk screws, but the one that they're actually flogging over here has normal screws on the top there, so they're proud of the heating pad, which means you can't actually put something on there and make it touch the pad if it's a little bit larger than the actual heating pad, which is not actually that big. And also, so I decided to have a look to countersink these myself, and so I took the thing apart, and then I found out that inside they were using some really poor quality ribbon cable with solid wire in it, not stranded wire. And as soon as I undid the screws, the little pins, the wires broke off the display, so I had to go and resolder that. And in trying to remove the display, actually the little display the contacts actually broke, and then well, I was able to use it without a display anyway, and I found out that it is kind of problematic. You have to have a special power supply, PD 65 watt minimum, 20 volts, and most of the power supplies that are around today, they don't support that anyway. It'll probably end up on 12 volts. In any case, and the top temperature would have been 240 degrees, so I started to think to myself, the little heating elements kind of useful. It looked similar to kind of heating pads that you find on 3D printers, but it was much smaller. So I decided to go and make a coffee mug heater out of it, which is what you see over here. I made up a larger piece of aluminium to put on the top of it so that it can actually hold the mug. The original one would have been too small. And anyway, as you will see, I used a little pulse width modulated control. I'm not actually using the controller board that came with it. So it was an interesting little project, and it is actually working very well as a coffee mug heater. So anyway, let's carry on and you'll see what I did. So what I have decided to do is that I have little or no use for this thing in actual fact. So I decided to use it for something else, and I got a piece of aluminium, and I am going to mount that on top of the little heating plate. And all these bits and pieces here, well, how it actually is put together is that they're all like little PCBs that sort of mount on top of each other, and you saw that on the little display here. See, there's like 3 PCBs. There's one inside, and then there's the controller board, and there is one underneath as well that you can't see. So and if you look at the let's bring in the other camera. If you look at the PCBs, they got little holes here, and what they are for is they have pogo pins. The spring-loaded pogo pins. They go through these holes, and the actual heating element over here is actually got 2 contacts there. So you might think by yourself, well, why didn't they just solder it on? Well, you can't, because if this thing actually heats up to 240 degrees Celsius, then solder would melt. So therefore they have designed it so these gold-plated pins contact these 2 pads over here. And so I'm going to put that together in a slightly different way than what it was, and mount this plate on the top. And I'm going to be using, I made up a bottom piece of PCB over here where the power is going to come in, and I'm going to be using this little control units. These things tend to sell on AliExpress for about 50 cents each, although they're usually on $2.50 for postage shipping. And these things actually, this is a control, and you can turn it off, and uses pulse width modulation on the output. And you can use these things for controlling little motors. I've used them for controlling an LED lights to dim them and so on. And they can also be used, they can draw up to 5 amps, these things, and this thing is going to be doing up to 3 amps, so it is well within its capabilities. And underneath this capacitor here there is a little microcontroller, and so we are going to use that to actually control the pulse width modulation, and we're going to run it at 20 volts because it was designed to run on 20 volts from the controller here. So let's have a look at the control. You might find that interesting what they have put on there. Let me get the microscope going here. So what's on that little controller board? Of course, this is the USB-C input, and that is actually driving this CH224K chip, which is a Chinese USB PD controller. It actually, depending on the programming of some of the resistors and what have you, it will attempt to negotiate a 20 volts from the USB supply. And indeed, if you've got a PD USB supply that can handle up to 65 watts, 20 volts, then it will do so. But there's a microcontroller over here, STC microcontroller, that actually is used to control the thing and display the output on the little display. But because that needs a lower voltage, there's a little buck regulator over here with a Schottky diode, and so that's pretty simple. There's not much else on there, just a little controller for the buck regulator, microcontroller, and this is the USB negotiator that will bring in the 20 volts. There's nothing on the other side, so that's what is on that little controller. So we won't be using this controller, we'll be using our own little pulse width modulator as we just showed. Okay, I mounted this thing on my little aluminium plate here. I put some thermal paste on there for good measure, which is only good for up to 200 degrees, but we're actually going to use this as a coffee mug heater. That's what I have purposed it for, and it doesn't have to go any higher than 80 to 90 degrees Celsius anyway. And these little pogo pins, they go in here like so. See, they're making a contact, and they're going to be mounted on this little PCB here like so. And I'm going to put it in this box over here. I think this is going like that. And I have a made up a little plate for it here, and I'm going to have to use some standoffs there. You should be just a little bit proud of this little box here. And this control is going to go through the hole, and I put a temporary sticker on there so I can mark the different temperatures on there, and then I'll make a proper little guide for it later on. So I'm going to be mounting that thing, and I'll see you guys when I've got that done, and then we're going to test it out. Okay, so I got this thing hooked up, and right now I got it set for about 5 watts, and it is about 54-55 degrees Fahrenheit. So let's increase it. Let's say 10 watts. I've got a little thermocouple which is connected to the VK Precision, but multimeter. But I've got the temperature set up to top left hand of the screen, and you can see the power supply, how much power it is drawing on the top right. Okay, it seems to be about 67 degrees. Okay, about 15 watts. Oh. Got some Kapton tape on there, which is heat proof, but still, I guess the glue gets when it gets hot. 72 degrees and still counting. 73. Okay, looks like it settles on about 79 or 80 degrees. Okay, 20 watts. Okay, let's call this about 90 degrees. It's actually gone up to 92. Okay, close enough. All right. Twenty-five watts roughly. Let me rearrange this a little bit. I don't know why they always put such stiff wires on these. Okay, we're boiling water. We're over 100 degrees C. Okay, The box is actually phenol formaldehyde plastic, also known as Bakelite. So it is heat resistant, and of course I put a metal plate on the top, so everything is insulated and heat resistant. Okay, 30 watts. $35. I'm going to make a proper dial for that. Once got it marked up. Okay, looks like about 156. Okay, well, it's been a bit of an adventure here. While I was off the video, I decided to run a few more tests, and then suddenly it wasn't drawing any more current. And when I opened it up, I saw that one of these pogo pins, this one here, you can see the difference, wasn't lost its springiness, and it was not making a contact anymore, and when I pushed it in, it was actually arcing. I suspected these little pins are not good for running up to 3 amps. So I went through my little parts bin and I found some screws, as you can see here, that I could fit in the holes. I then also found some little springs in my little... I tend to pull stuff apart and recycle everything, so I have a wide variety of bits and pieces. And then we have some of the plugs that I have, that power plugs, they have these little blades in them, so I used one of these blades. It has a little hole in the end already, which also fitted that screw, so now they are making a good contact. I've tested with the ohm meter, and move over a little bit maybe. Anyway, and I have connected it directly with spade lugs to this PCB. So now I've got to mount it on the top, and which I'll proceed to do, and then I can put it back in the box. So another thing that happened here is I took the terminal strip off and put these little bullet connectors on there, because that terminal strip was terrible. It was very hard to screw down and the wires kept falling out and so on. And another thing that happened to this thing is there is a MOSFET over here, and it actually short-circuited at some stage. So I replaced it with a new one, and now it is working fine. Sometimes when something goes wrong, everything goes wrong. But we will beat it. So I'm going to be putting this thing back in the little box now, and then we can do some more testing. So another thing that I've done is I have recycled an old laptop power supply that I'm going to be using with it. This is 19.5 volts power supply. Okay, this was the final test. I put some water on there, and I want to keep it at about 64 degrees C, or over 60 degrees. This is set to 64 degrees, and as you can see, looks like the camera slipped. It is doing about 30 watts, which is the minimum, and I can go right up to 35 watts if I want to heat it up more. And this goes to show you that when they sell these beverage warmers, or whatever they call them, they're running at 5 volts, 2 amps, 10 watts. It's not even going to keep lukewarm. It's just a joke. And another thing is that it'll only work if you've got this is a metal enameled mug with a flat bottom. That works. If you use a mug like this, they have a ridge at the bottom, it won't work either, because the heat will not transfer through the narrow little ridge. I mean, it might stop it from cooling down really quick. It might slow it down a little bit, but it won't keep warm. So that's the deal. So I am pleased this works, and I like to reuse things. It was obviously a cheap little PCB heater that wasn't very useful for what it was intended to, and it was poorly made as well. Those little pogo pins failed, and so I found a solution for that. Anyway, we're just doing this for fun, of course, and keep busy. So if you thought that was interesting and you like these kind of messy videos where we kind of make things up, then please subscribe, and I'll have some new videos soon. I've got some microcontroller stuff coming up, but I gotta read up on it first. And I've just recovered from COVID last week and a half ago. That's why there wasn't any videos for a little while. I've had it twice now, and each time it was just like an odd cold, a little bit of nasal digestion and sore throat and so on. And I am thinking that if you are healthy and you're fit, then COVID just becomes like, you know, yearly flu, or like a cold. You just get it and you get over it pretty quick. But if you are sickly, or you are eating too much processed foods and you're obese or whatever, it seems that people suffer much more, and they probably need vaccinations and booster shots. But I've decided the booster shots are really bad for me. I feel sicker with the booster shot than I do from COVID, so I'm not getting any more. Anyway, if you like the videos, as I said, subscribe and like and all that kind of stuff, and I'll see you guys later.